So, if EVs have got this massive battery underneath, then why do you need this little one? What on earth is the point of that? So, in an EV, it's got a big battery underneath. So between the wheels, behind that sill, a big battery sticking up, about 6-8 inches maybe, all in that big rectangle underneath. That big battery is sort of 350 to 375 volts. So it's high voltage, and it's high voltage DC. So the reason you've got a little battery under the bonnet basically is to run the computers, to run the ECUs, to do the safety checks, to turn that big battery on. Because the big battery has got a nice big fat cable, which is that one there. So down from the front of the battery, there's 2 connectors, one for high voltage and one for control. So a little comms plug, and then this big fat orange one, which has got positive and negative in it, and some earth shielding. So, but that is switched off under normal circumstances. Okay, so the car's parked, it's locked up, the car's kind of fully gone to sleep, and there are big contactors in the battery pack, and basically they're just big fat relays, and that turns off that supply from the main battery. Now, if there wasn't a 12-volt battery, the car would have no way of knowing whether it's been in an accident, whether there's some kind of dangerous situation, whether one of the orange cables is unplugged. If that supply was just permanently on all the time, you could unplug the plugs and you'd have high voltage in that plug. So under normal circumstances, the battery has got its big contactors, its relays, turned off, so they're open. So how is the car going to get power to turn the ECUs on, to do the safety checks, to make sure everything's okay, to know to turn that battery on? So that's the main reason, just for safety. So when you unlock the car, the 12-volt battery will power all the ECUs. There are a load of safety checks the car does, and as long as the car's happy, it will start that high voltage system. When the high voltage system is started varies car to car. A Zoe will start the high voltage system as soon as you unlock and open the door. That will come on, it will start charging its 12-volt battery. It's not ready to drive because it hasn't been started in the traditional sense. So it's not in ready mode, it's not ready to drive, but the high voltage system is on and active, the contactors are closed. Okay. Other EVs won't do that. They'll only turn on the high voltage system when you actually put it in the ready to drive mode. Okay. And if you're interested in a little bit more of the how the car can detect when these orange cables are connected, I did a member only video on what's called interlocks, which is basically the car's sensing of those plugs and whether they're connected or not. And you can join my channel. The membership is literally as cheap as you can physically make it on YouTube. It just covers the cost of making those little bit more in-depth videos. There's a member only chat, and also you can request if there's something you want to know. Someone requested how to do a gear oil change on a Zoe, so I'm going to do a video on that as well. So yeah, there's a link in the description. Consider joining the channel. So we've got the safety aspect of the car turning on and it knowing whether everything's connected. Also, if you think about the cars involved in an accident, the car's got G sensors and all that kind of normal stuff to know whether it's been in an accident. Obviously, in an accident scenario, you want to be able to turn off the big battery so that if any of these, if it has a big front end shunt and all this gets squidged up, you want to be able to disable all of this. So all these cables are off. And there's not obviously 400 volts going through those, 400 volts give or take. So you want to open those contactors, turn off the relays, but you still want to be able to use your lights, your hazards, your SOS system. They tend to have a little backup battery, but you know what I mean. You need, even if you've had an accident, you still want your lights to work for half an hour on the motorway, so it's mainly for safety. Now, interesting development. I've said, why is the 12-volt battery there? I haven't said it's essential to have a 12-volt battery, because what you actually need is you need a power supply, which is a low voltage, so it's safe, to power those ECUs. So you don't really need a 12-volt battery. That's not the requirement. The requirement is to have a power supply to power the ECUs. And some manufacturers are kind of going in this direction. So there are some Kia and Hyundai models where the high voltage battery has a separate supply. So effectively, you know, on this I said it's got its comms and it's got its high voltage, and there's only 2 plugs on the high voltage battery on this car. Some high voltage batteries in other makes and models have a low voltage output as well. So the car is powering itself from the big battery only, but that battery is producing a low voltage, sort of 14 volt supply to power the ECUs, so that then once it's happy it can turn on the main contactors, turn on the big supply. And Tesla are kind of moving in this direction as well. Yeah, so hopefully that is interesting. Just to say, although I mentioned some cars will only turn on the high voltage supply when the car's in ready mode, there are various other points at which the high voltage system may be active. So some cars will monitor the voltage on the 12 volt battery, and if it dips to a certain amount, will turn on the high voltage system, turn on the DC-DC converter. So the DC-DC converter is like your electric alternator. So it takes in your 375 volts, pushes out 14 volts, and that's sort of in the region of about 1.5 kilowatts normally as a general rule for EVs. So a nice beefy unit. It can supply lots of power, supply all the cabin things, recharge 12 volt battery, all that kind of stuff. You know, main beam lights, anything, fans and all that kind of stuff. So there may be various other times when the high voltage system is active. So another one, for example, is if you precondition the vehicle, that will fully wake up the high voltage system, and various other times. And sort of, as I say, it may just decide that it wants to come on and charge the 12 volt battery. So with an EV, you can't just presume that this is off. And this being a Zoe, I obviously unlocked it to open the bonnet. So the high voltage system is probably still active on this, and within the next couple of minutes, there'll be a couple of donks from the contactors and it will shut down. So some are more keen than others, but yeah, you know, for example, if you're going to do a 12 volt battery change on this car, if I unlocked it, opened the bonnet and said, right, I'm going to change this 12 volt battery, if I didn't know too much about EVs and architecture and different vehicles, we'd disconnect these 2 cables. Okay, brilliant. But there would actually still be 14 volts here on this with it disconnected, because down on this one, you can just about see a little red hat just down there. See that? Yeah, it's not so good in the dark, this camera. But that is the DC-DC output, and that's basically wired to here. And so you do need to be very careful when you're looking on an EV, working on an EV, that you can't just presume the high voltage system is off, okay? So it may randomly, not randomly, but it may, without warning, shall we say, just come on. Okay, so something to be a little bit wary of. But yeah, any questions or comments, let me know. If there's other interesting kind of EV things you're interested in and want to know, I'll be doing various videos. But yeah, if you want to get a bit more hands-on, in-depth sort of how-to videos that take a little bit more explaining, or you know, where I've sort of worked something out, had to pay to get information, all that kind of bit more juicy stuff, yeah, that's going to be in the member only videos. But hopefully that's interesting, and I'll catch you later. Cheers.